Good morning or good afternoon, Tigers. Today we'll be taking notes on 8th grade vocabulary. These are the basics that you need to know to be successful in 8th grade. If you understand this, you're way ahead of the game. Go ahead and split up your page in 3 sections. In the first section, we're going to be taking the vocabulary word or the term. In the middle column, we're going to be taking the definition. And on the third column, we will be drawing the SMP, having like so that we can have a model of some sort. Please make sure you write your last name, comma, first name, today's date, which is May 7th, and please put your class color. These notes will be stored in your class folders. You will not take them home. If you want to use your math notebook, you can. However, I want you to have a blank sheet of paper so that it's easier for you to just put in an 8th grade folder when you go to 8th grade. That's why I didn't say for you to put it in your math notebook. I wanted you to have it on a blank sheet of paper. And then at the end of the month, you guys will have a collection of maybe like 5-6 papers of 8th grade notes. And you'll be able to just put that easily into your 8th grade folder instead of carrying around your 7th grade notebook for those 8th grade notes. Okay, so this one is going to require you, this video is going to require you to pause. And the substitute will have to pause the video after I write a bunch, because I don't want you to hear me clicking and writing all the time. So our first definition is linear equations. A linear equation is an equation whose graph is a line. So I'm going to repeat that. A linear equation is an equation whose graph is a line. Here you go. So if I were drawing a picture, I would have to draw my coordinate plane, which is my x and my y axis. This is the x-axis. This is the y-axis. And we're talking about a linear equation. It looks like this. That is the line right there. And we can say that this equation might be something like y equals 1/2 x plus 1. That's just an example of it. And what we're really highlighting is that this line is straight. There's no squigglies around it like this. So we're worried about the linear equation. Next vocabulary word, solutions. Solutions are points on the line of the equation. So if I had to represent it as a picture, here's my x-axis, here's my y, and I had a line, a point. This one could be 0, 2, that's a solution. And let's say this one is 3, 4. So when you're writing a point, you write the x value first, and then you write the y value second. So in this case, we have the x value is 3 and the y value is 4. So 0, 2 and 3, 4 are both solutions to this equation or to this line. And when we draw a line on a graph or on a coordinate plane, we always end it with arrows to represent a line. So the next definition is really, really long, really big, but you know it as unit rate, constant of proportionality, and also as slope. So here is the biggest deal in 8th grade, slope. And what slope is the rate of change between any 2 points on a line. It's the measure of the steepness of the line. To find the slope of a line, find the ratio of the change and y to the change in x, rise over run. I'm going to write that. I'm going to pause the video, write it out, so you're going to need to pause it and write this little paragraph. So the slope is the rate of change between any 2 points on a line. It's the measure of the steepness of the line. To find the slope of a line, find the ratio of the change, y over x. In other words, rise over run. And when you rise on a graph, it's vertical, so it's up or down. And run is from right to left. That's horizontal. So rise you could put your arms up and down. Run is from your right hand or to your left hand. Now here's your SMP4 for this. Your SMP4, just imagine a X and Y plane, and let's say you're used to unit rate, constant proportionality, what's another word for it? Slope. So for every one pair of socks, it's $2. So for every one pair of socks, it's $2. Now let's say you buy 2 pairs of socks. Instead of $2, you just doubled, so it's $4. And for every 3 pairs of socks, it's $6, right? So that's like if we were drawing a graph, and our X would be our 1 pair of socks, and our Y would be our $2. So that's where I put the point 1 to 2. Then if it were 2 pairs of socks, it would be $4. And if it were 3 pairs of socks, it would be $6. My 6 is a little off, so hold on, let me fix it. I'll put 5. There we go. So that's a little bit more proportional. Now I connect those lines, and I draw this straight line. Remember to put your arrows at the end of your line. And what I represent here is for every 1 pair of socks, it's $2. So I go up to $2 and I go over 1 pair of socks. So 2, I rise 2 units and I run 1 entire unit. So my slope or my unit rate would be $2 to 1 pair of socks. So 2 over 1. That would be my slope or my constant of proportionality. Now I can keep going. From the origin or from 0, 0, I can go up $4. But if I spend $4, how many pairs of socks is that? Let's see. Go over to the point. So 1, 2, 3, 4. Now go over to the point on the line. 1, 2. So that's 4 over 2. Now, my constant of proportionality and my slope is still 2, or 2 over 1. But when I write my slope, I'm going to just write 2. But you have to understand that it's the price for 1. Slope can be 2, or slope can be 2 over 1. I forgot to explain this to you guys. I was originally doing this video, and it did not record my audio, so I have to go back and record my voice over what I draw. So you might see me draw something, but I forgot how I explained it. Don't worry if you don't understand slope very much right now. I'm going to explain it Wednesday, Thursday, Friday until the end of the year so that you have a grip or a good grasp on what slope is before you get to 8th grade. Just remember that slope in 8th grade means rise over run, or in your case, a unit rate. Now I want you to turn your page over, so flip it to the back side, and instead of having it vertically, I want you to have it horizontally. So I'm going to just draw you a quick little figure. Remember, I'm not an artist. Go ahead and flip your paper, turn it around, and then turn it like a hamburger instead of your hot dog. So it's going to look something like this. Now we're going to draw 4 vertical lines to evenly separate our columns. So I'm going to be talking about this first column right here. Then I'm going to move on to the second one, then the third one, then the fourth one. If you already used up all of your space, just pause the video, raise your hand, get a brand new sheet of paper, and then when everyone is ready, we'll start. And I'm going to start with box number 1, move on to box number 2, then box number 3, then box number 4. Now this next part, I'm going to ask you to really be on task because it's going to be hard to not giggle or laugh at some of these diagrams because I'm terrible at drawing and you guys love to make fun of my drawings. Remember, I majored in math, not art. Here we go. So my first section is going to be titled Positive Slope. And what positive slope means is a line that rises from left to right. So we're going to envision a mountain, like climbing, hiking. People love it, love to hike. Don't ask me to hike. Anyways, so this stick figure is very happy, very positive. So if you ever see a line on a graph that's from left to right, think of something positive, like climbing or hiking. So that's a positive slope. Now our next category, our second category, is a negative slope. And a negative slope is a slope that falls from left to right. Now here you can envision our stick figure is very sad because it's like if he was falling instead of climbing up this mountain or this peak or whatever it is that he was trying to conquer. So a line that falls from left to right. Again, don't make fun of my stick figure. Our third category is a zero slope. So when you think of zero slope, I want you to think of a horizontal line. And a horizontal line goes from left to right. So it is not up and down. It is left to right or right to left. It's just a straight, infinite line that's horizontal. I want you to think of our stick figure sleeping. He's knocked out and he's dreaming. He's in deep sleep and he has little Z's above his head. That's how I remember that's a zero slope, just Z's around like a thought bubble above you. Now our fourth category is this undefined slope. Now this is where our story turns kind of dark because we can't define slope if it's in a vertical line, if it's up and down or top to bottom. If it's an undefined slope, we really don't have a place for our stick figure, and he either dies or he has a parachute. That's not really a parachute, but whatever, you get the point. If you see a line vertical, that means it's an undefined slope or a non-existing slope.